In this video, we will know about exponential function and its properties, basically through graphs. We will know the definition and then we will see how exponential function and power function are different, though they look alike. And we will understand in this video. The video is going to be a very small video and we are going to understand it through graphs. Next session will be, we will know laws of exponent and laws of power, and we will apply laws of exponent and power to application questions. But we'll start the first session on exponential function and properties through graphs, because graphs is the best way to understand any property. Let's begin. So an exponential function appears in form of y is equal to a times b to the power x. A is a constant, b is a base, x is the exponent. The coefficient a should not be 0. The base should be a positive number but should not be 1. And exponent is a real number. Most precisely, an exponential function is in form of fx, which is a superscript x. So a is a number, x is a real number. So a is what? A is a positive number basically, and it should not be 1, and x can be any real number. Such kind of a function is called exponential function. We will be drawing graph for when a is less than 1 and when a is greater than 1 to understand very precisely everything about exponential functions. So more precisely, what is an exponential function and power function? Exponential function is expressed in form of, say for example, y is equal to 2 to the power x, or y is equal to 5 to the power. In place of x, you can take any real number like 5 to the power 7. So 5 is exponent 7. 5 is multiplied to itself 7 times. That is the meaning of exponent function. Power function would mean something that is written in form of y is equal to x square. Like if it is written y is equal to x square, we are talking about quadratic function. If it is y is equal to x cube, it is cubic function. So these are called power functions. But something in form of a number raised to the power another number, this is called exponential function. So that is the difference between exponential function and power function. Exponential function, like its properties will be like with common base, different exponent. Those are laws of exponent. Power function will relate. You can relate to like different bases, common exponent, how the laws will come, that one. We'll do more on the next session, but this session is basically on graphs. So first, let us draw the graph for the function y is equal to 2 to the power x. When we want to draw a graph, we want the coordinates. The coordinates can be x comma y. We'll take a good number of coordinates to get a distinct graph. So when x is a 0, y is a 2 to the power 0, which is 1. When x is 1, y is 2 to the power 1, that is 2. So this is what exponent will occur. You'll understand very beautifully what is the meaning of exponent through this tabulated data itself. X is a 2. So y is a 2 to the power 2, means what? 2 square. 2 times 2, that's 4. X is a 3. Y is 8. X is 4. Y is 2 to the power 4. Means what? 2 square times 2 square. 4, 16. Let's take some negative points so that we understand how things go, like if it goes for negative. The point is here base, in exponent function, base can't be negative. That is an important point to understand. So base is a positive 2 only, no? But x is a real number. X can be anything. So if x is negative 1, so it is going to be 2 to the power minus 1, which is 1 upon 2, which is 0.5. What about x is negative 2? So it's a 2 to the power negative 2, means what? 1 by 2 square, means what? 4, which is 0.25. Let's do some more points on this. Negative 3. 2 to the power negative 3 would mean 1 by 2 cube, means 1 by 8, which is 0.125. But you see, it's not turning 0 at any point. Except when X was 0, then y turned 1. This was x. And 2 to the power x was y, except that point. Minus 4, it's 2 to the power minus 4, which is 1 by 16. So right now, 1 by 16 can be a decimal number, which is very small decimal, of course. Let's draw the graph for this. Okay, let me see what tools we have for drawing the graph. Yeah, we have the tool. I'm drawing a straight line. Okay. So that was x-axis and this is y-axis. So x prime, y prime. Point of intersection of x and y-axis is origin 0. Let's plot these points on this Cartesian plane. So x0, y1 means what? That is a y-intercept. On x-axis, search nothing. On y-axis, 1. Assuming that every one grid is 1 unit. So this is y as 1. Then x as 1, y as a 2. 1 and a 2. X as 2, y as 4. Going so well. So this is a wonderfully done exponential function graph. See, exponential, it is growing. X is 3, y is 8. 3, no? 1, 2, 3, 4, 5, 6, 7, 8. Wonderful, wonderful. X as 4, y is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Definitely it's out of the coverage area. Then negative. X negative 1, y is 0.5. Somewhere here. X negative 2, y is 1/4. Means what? A little bit still closer, but not on x-axis. Negative 3, it is 0.125. You clearly observe whatever value of x you take, y is not turning 0. It is tending to be 0, but not turning 0. Let's connect these points so that we can clearly see the graph. The graph is this, connecting these points with free hand. This is how the graph of y is equal to 2 to the power x look like. This is called exponential growth. This is the exponential growth. That is the graph. So the graph will be going like this, close to x-axis, but pretty sure it will not intersect x-axis. So this is the first graph. So I hope you must have understood what is the meaning of exponential function through this graph. So graph will be rising function like this. Those are called exponential growth. Moving ahead. So this is what the information we should know about the exponential function. What happens when a is greater than 1? So we have just drawn a graph of y is equal to fx, which was a superscript x, means a exponent x. And here we took a as a 2. A was 2, which is greater than 1. When a was greater than 1, our graph was exactly like this. This is what I have drawn just now. So we considered different values of x and we got the corresponding value of y. We tabulated them and our graph came just like this. So this is what happens. So what happens when a is a positive number and greater than 1, the graph looks like this. Moving ahead. So say, for example, to understand more, our a, when it was a 2, the graph was this one. When a is a 5, so that base number increases, then so the graph steepness also increases. When a is a 10, you see the graph steepness increased. But for everything, the y-intercept was same. For everything, the y-intercept was the same. That means whatever be the value of x, we have different values of y. But when x turns 0, y value turns 1. Y value turns 1 because 2 to the power 0 is 1. 5 to the power 0 is also 1. 10 to the power 0 also 1. So for all exponential functions, y-intercept is 1. That is the first property we should understand. So for all exponential functions of the form y is equal to fx, which is a superscript x or a exponent x, and a is a number greater than 1. For a greater than 1, y-intercept is 1. The point on y-axis is 0, 1. That's a wonderful property. Second property that you should understand, that as a value increases, earlier when a was a 2, our graph was like not much steeper. When a was 5, the graph became a little bit more steeper. So it came closer and it was more steeper. When a was a 10, it went still more steeper. So as a value increases, means the base increases, the graph becomes more and more steeper. But this graph never meets x-axis. That is a point. It tends to be close to x, but it is not x. So properties of exponential function, first property, for when the base is greater than 1, the y-intercept is always 1. And as the base value increases, the graph becomes more and more steeper. And the graph never meets x-axis. 3 clear points, wonderful points, in fact. Now let's draw the graph for when a is less than 1. So here a is 1 upon 2. So this is a graph when base is less than 1. We have just seen when base was greater than 1. Let's create our tabulation, x and y. Now, when x is 0, y is what? 1 upon 2 to the power 0, which is 1. Wonderful. So that means that now also the y-intercept is going to be 1. Let's take x as 1. So y is just 1 by 2, means what? 0.5. X is a 2. Y is 1 by 2 square. That is 1 by 4, means what? 0.25. X is a 3. So 1 by 2 cube means what? 1 by 8. 1 by 8 is 0.125. Okay. Then let's take minus 1. 1 by 2 to the power minus 1 is actually, we have, okay, right now when we have not learned laws of exponents, now telling it, this one may not be right, but we can solve it and we'll get the same. So I'm just telling this one. So it is a to the power minus n is a 1 by a to the power n. In that case, 1 by a to the power minus n should be a to the power n. Okay. So this is going to be 1 to the power minus 1 divided by 2 to the power minus 1. 1 raised to the power whatever is 1 only. But this 1 will appear in the numerator, 2 to the power 1. So when x is negative 1, y is a 2. When x is negative 2, y is 4. When x is negative 3, y is 8. Let's plot these values. Let's plot these values on the Cartesian plane. So here we go. So that's x-axis. And we'll take the grid as a 1 unit grid. That's the y-axis. Okay, so that's x, x prime, y, y prime, and the point of intersection is origin. You have first, second, third, fourth quadrants, fine. Let's plot these values. First, we'll plot 0, 1. 0, 1 would mean 0 of x-axis and 1 of y-axis. That is the point. 1 and 0.5. 1 of x-axis and 0.5, and 2 and 0.25. 3 and 0.125. That's it. And then -1 and 2. Wonderful. Oh, the graph is raising in the left side. 2 to the power x, the graph rose in the right side. This time the graph is raising in the second quadrant. -2 and 4. Wonderful. -3 and 8. Still more wonderful. I'm counting it. 1, 2, 3, 4, 5, 6, 7, 8. Wonderful, in fact. Let's connect the dots. This sounds good, no? Connecting dots. Okay. When we connect dots, we know things. Okay. The secret is revealed. So we are revealing the secret. The wonderful secret here is, the graph is exponentially growing, but on the other side. Have you noticed something great? This is the graph for y is equal to fx, that is 1 by 2 raised to the power x. Here a was less than 1. And just now, just a little while ago, we have drawn a graph which was y is equal to 2 to the power x, and the graph grew like this. That was the graph for y is equal to fx, that is 2 to the power x. So wonderful. When a is greater than 1, the graph grows exponentially in the first quadrant. And when a is less than 1, the graph grows exponentially in the second quadrant. What a wonderful graph, and what a wonderful thing to understand. So this is called exponents graph. Moving ahead. So this is what we have just seen. A quick recapitulation of whatever we have seen. The important points, the important properties of graphs of these types of function. If x is 0, that means we had fx, that was 2 to the power x. So when f0 means what, x was 0, 2 to the power 0 was 1. So that was the first point. For whatever, for all values of a, that means 2 to the power 0 is 1, 5 to the power 0 is also 1, 10 to the power 0 also 1. So that was the y-intercept. 1 was the y-intercept. So because, okay, this actually, the first property gave, the first point was the first property itself for exponential function, that y-intercept is always 1, whether a is greater than 1 or less than 1. Okay. And when the function is greater than 0 for all values of a, the function is greater than 0 for all values of a. It's because a is a positive number. A to the power x is also a positive number. What happens when a is less than 1? We have examined just now. We have drawn the graph for this function, and we have seen the graph just rose exponentially in the second quadrant, but at any point of time, it doesn't touch x-axis. So clearly, three properties of exponential function. One, y-intercept. Whether a is greater than 1 or a is less than 1. Example, for 2 to the power x and 1 by 2 to the power x, for whatever be the case, is always equal to 1. That means the graph crosses y-axis through y is equal to 1. Second point, the graph never intersects x-axis. Never. It tends to meet x-axis, but never intersects x-axis. Never intersects x-axis. And the third point is also wonderful, that if a is greater, then the graph becomes steeper. Spelling check. the graph becomes steeper. That's a wonderful point to note. Like, I'm just doing the graph. When y or fx was 2 to the power x, the graph went like this. When the graph was for 5 to the power x, the graph went like this. When the graph was at 10 to the power x, the graph went like this. So graph becomes steeper and steeper as the value of a increases. Those were the three excellent properties of exponential function. You can pause the video for a while and note down these functions properties. That's the reason I started the first session with graphs, because graphs tell everything. And here also, when a value, so here, for when a is less than 1, what are the properties of exponential function? Here was the first one, the y-intercept is 1. Here the second property, that the graph never meets x-axis, just it tends, fx, just it tends to 0. It tends to 0, but never meet x-axis. See, it just goes closer to x-axis, becoming closer and closer to x, but never meets x-axis. And the third point, is as a value becomes smaller and smaller. The other time I was saying a was greater. This time a is becoming smaller and smaller. So when a was 1 upon 2, it was not steeper. But when a was 1 upon 5, it became steeper. But when a was 1 upon 10, as a value becomes smaller and smaller, the graph is becoming steeper and steeper. This graph is the steepest one, then this one, then this one. And ultimately, if you can imagine both the graphs on the same place. A value increases, graph becomes steeper, and a value decreases in case of when a is less than 1, graph becomes steeper. So here is the graph, and this graph is a wonderful representation of exponential function. So exponential functions look like this. When a is greater than 1, you find the graph in the right side in first quadrant. When a is less than 1, you find the graph in the second quadrant. And here, as the value of a increases, graph becomes steeper. And when a is less than 1, value of a reduces, the graph becomes steeper. Graph never meets x-axis, and y-intercept is always 1. So that's the session, guys. That is for the first session. We will do some worksheet questions in the next session.